All right, we're taking a look at equations 1 just to kind of make sure that we're all on the same page. So, equations 1, we're going to go do these first couple problems two different ways. A car accelerates from rest to 25 meters per second over a distance of 100 meters. How many seconds does it take to do so? So, if the car is accelerating from rest, what I want to do is kind of circle all of the information that it's giving me, circle all of my data, and we're going to underline the question. All of this requires some interpretation. So when a car accelerates from rest, rest is telling me that the initial velocity is equal to 0. To 25 meters per second, the final velocity is equal to 25 meters per second over a distance of 100 meters. So my delta x is 100 meters. And this is asking what's the time. So doing the guess method, initial velocity is 0. Final velocity is 25 meters per second. My displacement is 100 meters, and I want the time. That's my unknown. The problem is I don't have the acceleration. I can't really use any of the kinematics equations until I have the acceleration. So our first step is to find the acceleration. Here's a good general rule for kinematics. If you don't have the acceleration, the first thing you need to do is find the acceleration. So to find the acceleration, we want acceleration, and we have velocities and displacement. The only equation that has all that stuff in there is v squared equals v initial squared plus 2a delta x. I'm going to subtract over the initial velocity squared. Since we're subtracting it, that goes away. That side is left as 2a delta x, and now I have v squared minus v initial squared. So we'll divide by 2 delta x. Now we're left with multiplication and division. The 2 goes away, the delta x goes away, and I'm left with acceleration is v squared, so 25 squared minus v0 squared, 0 squared, over 2 times 100. We plug all that into our calculator, and the acceleration comes out to be 3.125 meters per second squared. So now that I have my acceleration, I can use any equation I want to find the time. So to find the time, since I have velocities, time, and acceleration that I'm looking for, this equation, the first one, v equals v0 plus acceleration times time, is the one that we're going to go with. So subtract over the initial velocity. So we have v minus v0 is equal to, because that goes away, acceleration times time. So we've got v minus v0 over the acceleration, because we're going to divide both sides by acceleration, is equal to the time. So we've got v 25 minus 0 over 3.125 is equal to the time. And I get 8 seconds. That's how we do it with the equations. We don't want to just do it that way. Sometimes it's more convenient to use the graph. Using the graph means using a velocity versus time graph. What's nice about this is I have two things that I know. One is that the slope is equal to the acceleration, which we don't have, so that could be helpful. The other thing is that the area of the graph is equal to the displacement. So if we take our information, we accelerate from rest to 25 meters per second. Now I want to know the time in which we do that. I don't really care about the acceleration, so I'm going to use the area to find the displacement. Well, that shape is a triangle, so it's 1/2 base times height is equal to the displacement. So my base is time, my height is 25 meters per second, and that equals the displacement of 100 meters. So multiply both sides by 2, divide both sides by 25, and that time comes out to be 8 seconds. Question 2, we have a child on a bicycle who hits the brakes to try to avoid hitting a large dog. It's going to take him 2 seconds. So, same deal, we want to look at our knowns, so we're going to circle him. He's traveling at 10 meters per second, skids to a stop, it takes him 2 seconds. We have this 8 meters bit, and we want to know if he avoids hitting the dog. So here's the deal. The initial velocity is 10 meters per second. Final velocity is 0 because we're coming to a stop. I'm going to do all that in 2 seconds. This 8 meters is not my displacement. Ultimately, what I'm looking for is my displacement. I want to compare the 8 meters to however far the child goes. So, since I don't have the acceleration here, well, let's do the graph first. Look at the graph. Again, it's velocity versus time. Start off here and accelerate down. Stop. So my initial velocity is 10 meters per second. Takes me 2 seconds to stop. So if I know that the area is equal to the displacement, here the area is 1/2 my base, 2 seconds, times my height, 10 meters per second. So that delta x comes out to be 10 meters. Using equations, the first thing we need to do is find the acceleration. So we're going to use v equals v0 plus at. V minus v0 over t is equal to the acceleration. So 10 minus 0 over 2 is equal to the acceleration. I did that backwards, sorry. 0 minus 10 over 2 is equal to the acceleration. So that acceleration comes out to be -5 meters per second squared. Then we need to find the time. Then we need to find the displacement. So delta x is v0t plus 1/2 at squared. We have that information, so 10 times 2 plus 1/2 times -5 times the time squared. 2 squared, that's 4. We'll plug all that in. The delta x still comes out to be 10 meters. Here we have a runner accelerating from rest to her maximum speed of 15 meters per second in 1.8 seconds, and we want the acceleration. Rest tells me that the initial velocity is 0. Maximum speed is our final velocity of 15 meters per second. And the time is 1.8 seconds. We want the acceleration. Well, all of that is in this equation. So all of that for acceleration. Subtract v0 from both sides. V minus v0 is equal to, that crosses out, acceleration times time. Divide both sides by time. And I've got 15 minus 0 over 1.8 is equal to the acceleration. So when we do that, the acceleration comes out to be, calculator real quick, 8.33 seconds is our acceleration. Go through the rest of this. This graph shows the velocity as a function of time. In the 12 seconds shown, the particle travels. So because this is a velocity versus time graph, one thing that I know is the area is the displacement. This is an odd shape. Because it's an odd shape, we're going to split this into areas that we know how to deal with. See what the best way to do that is. There. That's the easiest way to split it into shapes that we know how to deal with. So we've got this rectangle, 8 times 40, 320. We have this top triangle here, which is going to be 4 times 60 times 1/2. Uh, 120. And then this triangle down here, which is going to be 4 times 100 times 1/2. That's 200. And so my total displacement is 320 plus 120 plus 200. Giving me a total displacement of 640 meters. For 5, we have a Triumph sports car starting from rest. Tells me the initial velocity is 0. Getting to a speed of 27 meters per second. I mean, the final velocity is 27. 11.8 seconds. Calculate the distance that the car travels during this interval. So, the initial velocity is 0. It says that we start at rest. Final velocity is 27 meters per second. Tells us that's what we're getting to. And the time is 11.8 seconds. And we want the displacement. In this case, we don't have the acceleration, and I'm okay at this point saying that if you don't have the acceleration, more than fine to just jump to using the velocity versus time graph. We're going to start at rest. We're going to get to 27 meters per second. It's going to take us 11.8 seconds. So I know that my displacement is equal to the area of that graph. So my displacement, what we're looking for, the distance that we travel, is going to be 1/2, because it's a triangle, base 11.8 seconds times the height of 27 meters per second. Comes out to 159.3 meters, which is really close to 160 meters. Number 6, an elevator is moving upward with a speed of 11 meters per second. 3 seconds later, it's still moving upward, but its speed is 5 meters per second. It's doing that in 3 seconds, and I want to know the acceleration. So the initial velocity is 11 meters per second. Up, the final velocity is 5 meters per second. Still up, time is 3 seconds, and we want the acceleration. So for that, we're going to use v equals v0 plus at. We solve that for the acceleration. It's v minus v0 for time. So 5 minus 11 over 3 is negative 6 over 3, negative 2 meters per second. None of these things have negative signs on them, so what we're going to do is say that this negative sign tells me that the direction is opposite to the directions that we were talking about that we made positive. It's 2 meters per second squared downward. And we should note that this makes sense. Our object is slowing down. Landing airplane makes contact. What's the average acceleration of the airplane? So it makes contact at an initial speed of 78. Moving towards the south, so I'm going to go ahead and call that south. After 18.5 seconds, the airplane comes to rest. So 18.5 is my time. My final velocity is 0 meters per second. We've come to rest, and we want to know the acceleration of the airplane. That's the exact same thing that we had before. So the acceleration is 0, the final velocity, minus 78 meters per second divided by the time of 18.5 seconds. So my acceleration comes out to be negative 4.22 meters per second squared. A negative sign means we're in the opposite direction of whatever we called positive. We called south positive, so that 4.22 meters per second squared is going to have to be north. 8 through 10, an object starts from rest, so my initial velocity is 0 and accelerates uniformly in a straight line in the positive x direction. After 11 seconds, its speed is 70 meters per second. First thing we want is the acceleration of the object. Again, it's the same math that we've been doing for the last 2 questions. The acceleration is the change in velocity, v minus v0, over the time. So 70 meters per second minus 0 meters per second divided by 11 seconds. So my acceleration comes out to be about 6.4 meters per second. It's positive. Those little boxes are for negative. How far does the object travel in this 11 seconds? Now I need the displacement. Since I have all my numbers, it's convenient just to do the equation. v0t plus 1/2 at squared. So it's 0 times 11 seconds. That whole thing is 0 plus 1/2 times 6.4 times 11 seconds quantity squared. So 1/2 times 6.4 times 11 squared. It's about 390 meters, so 387 is what I got in my calculator. And then what's the average velocity for the whole thing? So for average velocity, we don't really care that it's accelerating. For average velocity, we're going to do change in position over change in time. My entire change in position is 390 meters. And my change in time for the entire interval is 11 seconds. So my average velocity is just 390 divided by 11. Roughly 35.45 meters per second. So roughly 35 meters per second.